Reducing carbon emissions globally requires not just clean energy sources, but the electrification of transportation and the advancement of distributed energy resources such as solar, wind, and battery storage. Integrated distribution planning is a core platform for this analysis, supporting the planning, justification, timing, and implementation of infrastructure capable of net zero carbon. Hi, I'm Tom Anderson, Principal Engineer with the SAS Energy Practice. I have partnered with Dr. Prasenjit Shil of Ameren. Together, we will share reporting and analytics that we use to uncover how well a utility is performing to achieve net zero carbon initiatives. Although carbon is a complex topic, there are many data sources we can use to determine how well a utility is performing. Capital planning, asset optimization, electric vehicles, climate and demographics are examples of some of the types of data that we can use to determine success of a net zero initiative. We will be using electric consumption, amount of renewables, and other sources of generation serving those customers, along with electric transportation statistics, to estimate the net carbon footprint in the utility's service areas. The goal is to assign a carbon score based on these parameters within service areas of the utility. During this presentation, Dr. Shil and I will explain those data sources and provide an example of how to report and analyze the utility's performance to achieve carbon neutral. In doing so, we will introduce a duck curve analytic that provides a visualization of the net carbon impact on an hourly basis within the utility's service area, as well as system-wide. With the Climate Emergency Declaration for Carbon Neutral, carbon reduction becomes a main focus for many utility industries. While there are many ways to approach this problem, we believe our methods and practices will provide a starting point for many utilities as they continue to address this ever-important challenge. We will be using SAS Visual Analytics and SAS Visual Statistics in our reporting and analytic process. We hope you enjoy the presentation. Thank you.
Thank you, Tom. Hello, everyone. This is Prasenjit Shil from Ameren. Ameren is a fully regulated electric and gas utility company based in St. Louis, Missouri. In the Missouri jurisdiction, which is vertically integrated, Ameren owns nearly 10,000 megawatts of electric generation capacity. It serves nearly 1.2 million electric customers in each of Missouri and Illinois jurisdiction. In Illinois, it also serves approximately 1 million gas customers. As a regulated entity in Missouri, Ameren Missouri publishes Integrated Resource Plan, or its short IRP, which outlines its generation and environmental strategies to its stakeholders every 3 years. In its most recent IRP publication in 2020, Ameren Missouri has established a net zero carbon emissions goal by 2050 across all of its operations in Missouri. The goal has been established for Ameren, Illinois as well. In addition, Ameren Missouri laid out plans for its largest ever expansion of clean wind and solar generation that maintains the reliability and affordability that customers expect from Ameren. For details, please refer to Ameren's Environment and Sustainability website as listed below. In the 2020 IRP filing, Ameren Missouri clearly outlines how it plans on transforming its generation portfolio to achieve goals of net zero carbon emissions while maintaining the customer affordability. This is the driving force behind Ameren Missouri's plan for meeting its customers' future energy needs. This plan significantly increases investments in wind and solar generation, advancing the retirement of coal-fired generations, and putting the company on a path to net zero carbon dioxide emissions by 2050. The 2020 IRP represents a step change in the execution and realizations of the generation strategy that guided the resource planning for most of last decade. Ameren's stated goal to achieve net zero carbon emission is the first in the industry to establish commitments to significant long-term reductions of CO2 emissions. Ameren Missouri invested in 700 megawatts of new wind generation, which will be in operation and will provide a clean energy to our customers in 2021. Ameren Missouri's transformative plan includes adding nearly 3,100 megawatts of wind and solar generation by 2030, 5,500 megawatts of wind and solar generation by 2040, retire all of remaining coal-fired generations by 2042, and achieve net zero CO2 emissions by 2050. In doing so, we will also support the decarbonizations of our region's economy through efficient electrification of transportation and other sectors that currently require fossil fuels. Ameren Missouri is targeting 50% reductions in CO2 emissions by 2030 and 85% by 2040 with the goal of achieving net zero carbon dioxide emissions by 2050. These reductions are based on 2005 levels. Even as we achieve these more aggressive reductions in carbon emissions across our own fleet, our planned renewable resource additions will result in significant additional carbon emission reductions across the region. Additionally, energy efficiency and demand response programs are expected to contribute to carbon reduction by reducing total demand. By 2040, these programs are expected to result in nearly 2,000 megawatts of peak demand savings. In addition, the efficient electrification will help in transforming traditional carbon-emitting resources for heating and transportation purposes. Ameren is not the only one chasing net zero carbon strategy. Utilities such as Entergy, Southern Company, etc. are adopting to net zero carbon strategies. Utilities are not the only ones either. With changing consumer expectations and frankly to improve its own cost basis for energy consumption, non-utilities too are targeting zero carbon future. Companies such as Microsoft, Google, Nike, Starbucks, Unilever, Wipro, as well as Environmental Defense Fund, all these companies are trying to find a way to create a net zero environment for its own benefits as well as its own customers' benefits. CO2 emissions among utilities in general are declining. Based on EIS reporting, CO2 emissions declined 28% since 2005 level and will continue to drop. Many states and cities are aggressively pushing the low carbon initiatives as well. One of the useful ways of comparing CO2 reduction is per capita carbon dioxide emissions. Many factors contribute to variation in the amount of emissions per capita, including climate, the structure of the state economy, population density, energy sources, building standards, carbon intensity, and explicit state policies to reduce emissions. States with higher carbon intensity, which reflects the energy fuel mix, tend to be the states with higher per capita carbon emissions. Tracking impacts of relevant carbon reduction measures are a little complex, which highlights the necessity for innovative reporting and analytics for better stakeholder engagements. This presentation focuses on innovative presentation of the carbon economy in the utility spectrum. Now let's move into the dashboard work that we have done. These dashboards summarize total EVs and PVs in the system and gives a simulation tool to estimate carbon reduction statistics from various levels of EVs and PVs installed. These dashboards enable the users to view the statistics at the zip code level as well. The first dashboard here is the total summarized version of the carbon impacts. The rest of the dashboards deals into the individual pieces of this overall dashboard. To begin with the carbon score is essentially the carbon dioxide reduction per capita. The carbon intensity score is the total carbon emission per kWh of output. Total carbon reduction is calculated using the estimated carbon reduction per kWh production as published by EIA. The bottom part of this chart shows the breakdown of the major carbon stats by the EV and PV. The dashboard also shows the system load shape with PVs and EVs added on and highlights the duck curve. The stats in this section corresponds to the stats at the top of the dashboard.
So as we select this,
particular zip code, for instance, we can see what our EV carbon reduction is for this area, what our PV carbon reduction is, and the percent of carbon reduction that we currently have obtained. Adding the sliders up here allows us to look at potential growth. So let's say if we're going to adjust our PV and say we're going to have a 35% growth, we can see what that does to our carbon score to increase the impact of net carbon. So in this example here, you can see by adding 50% more EVs and adding 35% more solar in here, we can increase our CO2 reduction to 21%. And our carbon score actually goes up to 0.08. What we've seen is that the closer that we get to 1, that's the closer till we get to that net zero. So our goal in here by 2050 is to actually have this to a level of 1 point some value. As she was mentioning through here, if we look at system load across here, we can see the contribution of solar to our electric vehicle load at night on our current load shape. And the duck curve illustrates this as we see the load shape change as we add solar rooftop generation in contrast to our load profile that we have, our generic load profile. Now let's take a look at our other reports that we've generated, particularly here with alternative fuels. Now the alternative fuel vehicles that we have here, we have many of them. Natural gas, hydrogen fuel cells, flex fuels, diesels, and hybrid gasoline. Our main focus in our analysis was working with batteries and the impact that battery EVs would have on our systems. Much like we had in the previous report, we can select based on the zip code to see what our total carbon reduction would be based on the values we had in our slider in the previous report. We can see our estimated carbon reduction, how many vehicles we're adding, and the total vehicle count would be our target. Also down here in the bottom right, we can see that we have 306 current battery vehicles registered, but we have 40,000 gas-fueled vehicles. That means that there's a good impact that we can make on our carbon reduction by converting many of these, or just even a fraction of these 40,000 vehicles from fuel to alternative vehicles. In the center here, we have the adoption rate. And as you can see here, we have a crude cumulative adoption rate from 2005 all the way through 2017 and some part of 2018 as far as the data that we had at this time. Let's look at our PV installations. So we're looking at solar rooftop installations based on specific zones in here. So if I look at a zip code, I can bring that up, see the service city it is, the zip codes reflected of the total capacity that we have within these systems. So 7.7 megawatts is what we have at total capacity within these systems, and commercial and residential breakdown. We also report on the total residential, industrial, educational, and commercial segments that we might have. And on the upper left-hand side, looks at our installation adoption rate here. And as you can see in 2016, there was an incentive program. So we had a lot of influx of solar PV installations at that time. We wanted to add a forecasting element to this. So we took a look at the solar installations based on zip codes and residential or commercial or industrial or basically our customer segments to produce a solar output or solar generation forecasted model. And here you can see we're going out about 5 or 6 days forecasting what the generation would be. And we do this again by zip code as well.
The solar forecast that we do here can also help in different planning, so different operational planning purposes, such as day-ahead bidding. When the system has a lot of solar or wind generation, it would be necessary that the system operator looks at those forecasts and make operational changes as necessary.
And then we went to we wanted to look at this at a financial aspect as well, and we thought this was quite interesting. So looking at our load again, we're bringing in data, 8760 data across this, in both of our forecasts actually, hourly intervals, and we calculated what the customer savings would based on the generation of rooftop. And again, we can select this based on our different customer segments, and here I've selected commercial, industrial, and residential. And for this period of time, as we look at the PV cost savings, basically the reduction in cost due to the solar installations and generation that we have, our total solar capacity is at 95 megawatts. Our total production was at 17 gigawatts over this period of time. This brought in a customer savings of $1.4 million. And that's looking at a per capita of about 1 million customers. But again, we can select a specific zip code and drill into the details on this. So we could look at the system capacities on that particular zip code, the amount of production or generation that we had, or production of kWh that we've created on here, and look at the customer savings based on that region, which is $115,000 in here.
It's important to note that the savings are for the days that were selected at the beginning. So if you look at the left side of this dashboard, it shows 6th July to 27th October. So this data represents those dates.
And we also wanted to add in a generation profile, essentially looking at the load shape based on our customer segments over an 8760 reporting. And here you can see over our systems here, which is about, again, 1 million customers. This is our load shape of solar based on residential, commercial, industrial, nonprofit, and governmental agencies. We can see that load shape in the seasonal impact that it has over the 2018 year. And below here is the average hourly load shape that we have from each one of these. And again, we can select this based on zip code or sections on this. And it's worth mentioning that going beyond just on a zip code regional area, that we can produce this as well looking at circuits and circuit sections if we look at the grid design, the actual physical lines within the infrastructure that we're reporting on.
This dashboard also helps the utilities to identify overloaded distribution network or zip codes or networks that have higher demand profile. This helps in targeting appropriate customers for demand response or other demand shading programs, or even design a more reliable distribution network. Over the last decade or two, analytics and Internet of Things have improved so much that big data analytics can be easily done in near real time or in real time. Machine learning approach, AI-based optimizations can potentially chart the life cycle of every kWh generated and consumed, thereby identifying opportunities to minimize the carbon footprint in systematic manner while maintaining grid reliability at its highest point. This presentation is merely a tipping point. Machine learning and AI-based routines can predict customer behavior, vehicle usage pattern, and topology of those in grid, which may even produce more prosumers who could trade excess energy among themselves, thereby reducing the footprint. Google used DeepMind to study historical energy consumption patterns to develop neural network models and was able to reduce energy consumption up to 40%. This is just an example of how AI helped Google greening its own carbon footprint. More to come in the future. Hope you enjoyed this presentation. Thank you.